Hello fantastic people, I hope you are doing great. So today I hoped to release a video about procedural generation, but unfortunately I realized that it pretty heavily relies on the grid system I created, so I thought it might be beneficial to create one together first. So let's get started. So here I have an empty project, and I'm starting by creating a folder for my scripts. So let's call it scripts. Then inside of it I create a class called grid. Now let's open it. Okay, so here we have our script. First thing we have to do is to remove the extension of the monobehavior type, and because of that we don't need also the using Unity engine. Why we do that? Basically our grid won't be attachable to any game object. Basically there is no sense in doing that. It will become part of other scripts that will attach to game objects, but itself directly will not be attached. So our grid will be able to store anything. So not only, I don't know, integers, but all primitive types, all objects, and so on, so on. So in order to do that, we have to make it generic. In order to do that, I'm adding the generic type after the name of the class. By the way, somewhere there should appear link to the tutorial about generics if you don't know what I'm talking about. Now, because we have that, what we can do, we can create generic container for all our cells, and that would be in our case an array. So array which will be called cells. Then we need two fields for the dimension of the grid. So public int width, public int height. Awesome. Now using this data we can initialize the cells. So let's create a constructor. So we want to get width, we want to get height, awesome, and we want to initialize the array. So new t with the size width times width times height, and of course we want to assign those to our variables, so width and height. Fantastic. Okay, so that will make sure that our grid knows about its dimensions and it has the place to store the actual items. Of course, we don't want our cells width and height to change over time. So what we can do, we can simply provide a getter to each of them. So that will make them read only and accessible from outside. So we will be able to set them in the constructor, but if we even create another method, so public void test method, we won't be able to do, for example, width 5. We cannot change it because the property doesn't have a setter. So this is way of securing our implementation a little bit. Okay, so you may be wondering, how is it possible that we are using one-dimensional array for two-dimensional grid? This is a little bit unintuitive, I agree, but this simplifies a lot of implementation details because we always work with only one collection. So whenever we want to search for an item, we don't have to look in multiple collections. We always use this one here. So this is pretty amazing, but this means that we need to have a trick or use a small trick to convert y and x coordinates to index and the other way around. So let me open Photoshop to show you how basically this is going to happen. So we have two data collections, obviously. We have our, I'm not drawing, yes, okay. We have our array, which has, let's say, 4, 5, 6, 7, 8, 9, so that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, we have 10 cells, right? So the first index is 0, and the last one is 9. Then we have our grid. And this grid over here has the width of 2 and the height of 5. So 1, 2, 3, 4. Amazing. So that means our coordinates over here are 0, 0, right? So this grid cell is 0, 0, and that means that this over here, so this is 0, 1, so this will be 1, and here on the top will be 0, 1, 2, 3, 4, right? So we have those maximum coordinates in our grid. Now, how do we convert from one to the other? Let's say we have 5 dots, 1, 2, 3, 4, 5, and intuitively we would know that those would be placed as 1, 2, 3, 4, 5. Okay, so now how to convert one to the other? Here we have index 4, so we have index 4, and we somehow need to convert that into coordinates 0, 2. How do we go about it? There is actually a formula for it. So what we have to do, we have to first, for the x, we make modulo of 2, or index modulo 2, I guess that's how you would say it. So basically, if you don't know what modulo is, it's an operator that gives a the rest after division of integers. So if you have, for example, I don't know, 5 modulo 2, if we would divide those integers, like in programming, for example, right, we would basically receive 2. So this would be 2. There would be no rest, so there would be no floating point thingy here, right? So no places after the dot. But after we do that, obviously we still have somewhere 1, right? The rest of the division. So that is what the modulo returns. So basically it gives whatever stays. So I don't know, if we would have 5 modulo 3, that would give us 2, because the division would give us 0, but 2 would still, sorry, the division would give us 1, and 2 would be still left. So that's what we would get using modulo. Okay, clean it up. So here, for that, we have 4 modulo 2 gives us 0. So that is correct. For y, what we do, we divide I, so the index 4, by the width of the grid, and that gives us 2. So the formulas once again are I, so the index, right, modulo of width, that gives us x coordinate, and I divided by width gives us the y coordinate. Awesome. So here we have one way. Now we need to convert the coordinates into the index. So what we do here, we take the coordinates. So let's say once again we have this one. So we have 0, 2, and we know we want to convert it to 4. How we do it? This is very easy. What we do, we multiply our y coordinate by width, and then add to it the x coordinate, and that gives us the index. So in this case we have 2 times 2 plus 0, that gives us 4, which is correct. If we, for example, would like to get the index of this one, so the coordinate would be 1, 1, that would be 1 times 2 plus 1, which gives us 3, which would be this dot. And I hope that's clear. So now let's implement it. Okay, so it's time to put it in our script. So we need 2 methods. First one that will return our return us the index given x and y. So for that we can do coordinates to index and int x, int y, And then the formula we've seen, so it will be return, and it will be y times width plus x, as easy as that. So we have that. And then the other way around, public vector to int. So vector to int is basically x and y together in y vector, in one vector, and it has to be integers. What's for us much better than using a regular vector 2, because we would get back floats, which then we would have to cast to integers and so on. So here we have vector to int, and the method would be called index to coords. And now we get index, and we want to convert it again using the formula we had, and we return the new vector to int. For x it's index modulo width, and for y it is index divided by width. And we don't have to round it down, because when we have operations on the integers, the rest of the division is just discarded. So here we have those two coordinates, so we have a way of easily changing from one system to the other. Now it's time to allow the user of the grid to set the items. One thing that you may actually see straight away is that we have different ways of storing the coordinates, right? So we have the vector to int, we have separate x and y, and in a sense, the index is also a coordinate for us. Maybe not directly, but it can be easily translated, and it definitely can be used to retrieve an item from the grid. So it would be good when creating and set and get methods to actually overload them to allow usage of all of those types of coordinates. So that's what we'll do. So first, let's create set methods. So public void, because we don't want to return anything, set. Now obviously we want to accept the first type of coordinates, and then t value. So that's new value of a type that we store in the grid. Once again, it can be anything. It could be float, integer, mesh, it could be game object, anything. So as beautiful, as useful as that. Now the only thing we have to do is to add it to our grid. So cells. Now we use our method to convert those coordinates into the index, because obviously we put things in the array, so we always have to do it by index. So coords y xy, and now equal value. So we override the value. So we have the first one. Now we create two other. So public void set vector to int coords, and once again t value. Now we set it. Okay, and coords x, coords y, and that's awesome. Yes, that's all. And now the last one, which will be the easiest one, the int index t value. And now here we are. And no, we don't need the whole method, we simply provide here the index. And now we have three ways of setting the item in the grid. Now, very similarly, we need three ways of getting the items. So the easiest way will be to copy and paste those three methods. Now, remove the parameter value, because for this one we won't be providing anything. The same here, we can just remove the assignment and return it. So once again I can copy and paste it. And now once again, because we can return anything, we just provide the generic type of the grid. Awesome. So we have set, we have get. Actually, one thing that we can also add, because we already return the coordinates in the vector to int, would be good to also have methods to convert them into the index. So let's create another coords to index method where we accept the vector coords, and we simply return the other implementation of this method that accepts x and y. So now our grid is pretty usable. It's easy to work with because you can use it different ways, whichever you prefer, or you don't have to convert one data type to another one. You can simply work with what you have. This should be a solid base. This is actually already solid base for a good grid system, but I like to add some more methods to make it even more usable or more easy to work with. So the first thing that is very helpful, but is not directly part of the grid, but makes working with it much easier, is direction enum. So I like to have enum called direction, and that stores 4 different values, and obviously those can be up, down, left, right, or north, south. I prefer the cardinal directions, so I'm going with north, south, east, and west. So here we have those 4 values, but for them I like to add extension methods. If you don't know what extension methods are, you can see a link above my head pointing to the tutorial about them, because this makes really working with them a little bit easier. So I'm creating here, generally I would create a separate class, but because in this enum there will be not much and those extensions will be directly related with it, I'm going to keep it here. So I'm making public static class called direction extensions. Ooh, beautiful. And now I'm going to create first method that will convert the direction to a vector, right? Because when we work with a grid, very often we want to move one grid up, down, left, right, or we want to basically check the neighbors and this type of stuff. And normally you would have each time to construct a vector for that. This way you work with more readable things, so there is a smaller chance of you making a mistake. So I really think this is very useful. So public static, and the returning value will be vector to int. And now we want to call the method to coords. And what we do, we accept this direction self. And now we simply check which one value we have, right? So if self equals north, then we will convert it into a switch statement in a second. So that then return new vector to int, and in x-axis it will be 0 because we're moving up, and to move up we need to give 1, right? Because in the coordinates, in the unity coordinates, the higher we go, the higher we go, the bigger number, right? Okay, so here we have this. Then if self equals direction south, then return new vector to int 0 minus 1. Now if self equals direction east, return new vector to int, and now 1 and 0 because we want to go to the right. So from your perspective that's probably your right, but you get the point. Now if self equals direction west, then return new vector 2 minus 1 0. Now we convert it nicely to switch statement, and then even better, we add, obviously because we have to always return something, so we also create default with the argument out of range exception, and then we convert the switch to expression. And we have this beautiful short method that allows us to convert the coordinates, the direction into coordinates. Now would be great to have thing that will allow us to do the same thing the other way around. So public static, and now we want to return direction and to direction, and this will be extending vector to int self. And now if self equals, we could actually do that. If equals that, then return north. We can duplicate it 4 times, then do that, and then we can just return, or we can throw new argument exception, because it's not out of range, it's just a one that we don't know how to convert. So we have those two useful methods. So now we go back to our grid and create some methods over here. So the first one would be good to have a method that allows us to validate the coordinates. So what we can do, we can create a public method that returns bool, and let's name it our coords valid. Now int x, int y. And how do we know if the coordinates are valid? So basically our coordinates, our x has to be larger than 0, obviously. So x it larger or equal to 0, but at the same time x has to be smaller than the width of the grid. So we use width. That checks for us the x coordinate. Now let's have a look at the y coordinate. So again, y coordinate has to be bigger or equal 0, and at the same time it has to be smaller than the height. Awesome. That is the basic check that we need to do, but sometimes there is situation, I actually find it true more often than not, there is situation when we want to like treat in, for example, let's imagine we create a dungeon, right? And we use the grid as a base of for our dungeon. And at the beginning, we obviously want to fill all the grid with tiles. But then when we, for example, generate the dungeon, we want to leave the border around, right? So we cannot touch the walls. So if somebody tries to remove the outer wall, we want to say, no, this coordinate is invalid, you shouldn't touch those base, those walls. So how do we go about it? We can just simply add here another parameter of type bool and call it save walls. And as default, just let's make it false. And now, whenever it is false, that will be the check for the save walls, however. So when the save walls are true, what we want to check is slightly different. First, our x has to be larger than 0, right? Because the 0 cannot be modified because that's the edge. The same, x not only has to be smaller than width, but it has to leave one, basically a margin of 1, right? So -1. The same here, it has to be larger, y has to be larger than 0, and for height, it has to be smaller than height -1. Now, for it to work, we need to add colon, and we have this beautiful thing here. And this gives us ability to have two different methods using one method. Obviously, we could separate it to two different ones if you prefer it this way, but this will work well too. And also what we can do, we can create another one, bool r coords valid. Once again, we vector to int coords bool save walls false, and just call the other one. So return r coords valid, coords x, coords y, and save walls. Fantastic. So we have those methods. I completely forgot to mention that you will be able to find all of this code in the repository linked in the description. So in case you got lost or you just don't want to write all of it, just use it. No problem whatsoever. The link will be in the description. Now, another useful method will be converting, or maybe rather finding the coordinates of an item that could be potentially in the grid. So for that, we want obviously to return vector to int. We can call the method getCoords. As a parameter, we want the item that we'll be checking. And now first we have to get its index. We do it using the arrays method called indexOf. And we provide first the actual array and then the value that we are checking. In case this is not found, basically we will get -1. So what we do now, if the value I is -1, that means we didn't get anything. So it would be good to throw an exception. Throw new argument exception. So we haven't found it. Now, otherwise, we simply return the index to coords with the index. Boom! And we have that beautiful method. Okay, so now it's time to implement the last method, which is also very useful, and that's getting the neighbors of a cell. So we want to create a public method, which will return a list of t, because those will be the items around. Now what we do, we get, we name the method getNeighbours, and our parameter will be vector to int. So those will be coordinates of the item that we want to get the neighbors of. So what we can do now, because we have the enum for the directions, we can go to, get values of all directions, right? So directions, and that will be basically enum get values, and basically the enum type would be, let's check if I can do that. Direction. No, it's not generic. So what I have to do is I have to do type of direction. And this will return me a list of all 4 directions. Not list, but an array. So what I can do now, I can, for each element, so for each var direction in my array of directions, that should be in, and let's just make sure that it knows what it is. So let's make direction. Now it's a little bit easier to work with. Now what we can do, because we have those extension methods, we can very easily get new coordinates. So neighbor coordinates would be the coords that we provided as an argument, then direction 2 coords, and now we have new coordinates. You see how easy and beautiful that is? Now we have to check if those coordinates are valid. So what we do, neighbor coordinates, if the coordinates are valid, so neighbor coordinates, then what we want to do, we want to add them to the list, which we forgot to create. So for neighbors And now new list of t. And now neighbors add get, not get item, but simply get, and item of with this coordinates. Why it doesn't see the get method? Of course, because those should be called get. Okay, so we have those, yes, we have this neighbor. And what we can do after this loop ends, we can return all neighbors. And this way we have all neighbors. If we would like the walls, we could, for example, here make the check for save walls, bool save walls, and once again provide it lower to the R coordinates valid book. Beautiful. And ladies and gentlemen, that's the last useful method. In the next video, we'll use this grid system to generate random caves. I hope you enjoyed it. Have a fantastic day. Love you and bye bye.